the reason the Department of Energy did Wind Vision was really to help inform local, regional, state, and federal policymakers and decision makers to have a better insight into the real value of wind into the system. So understanding what the costs and what the benefits are, having a clear perception of many misunderstandings and myths about wind, understanding the potential about wind, all were part of the Wind Vision effort. Was really an attempt to see if the Department of Energy had the ability to align a number of different organizations and agencies to be able to mobilize themselves to be able to figure out what is it we really need to do to help wind create its best value in the electricity portfolio grid. Okay, let's see if I can get this page work. So many of the group here may be familiar with the original 20% wind by 2030 report. That report was based on 2006 data, and it was a report that was issued back in 2008. And it really tried to answer the question, is 20% wind possible? Do we have enough resources? Can we do the manufacturing? Can we build it? And that report made the projection back in 2008 and said, you know, we can. We have enough resources. Wind can become a major player. Back in 2006, when this was originally drafted, wind was substantially less than 1% of the total electricity generation in the United States, and really wasn't a major player, and it wasn't known if it was a major player. The 20% report answered that question, or projected to answer that question, and said, you know, we really do think that wind can be a material contributor to the overall energy portfolio mix. The Wind Vision project that we did here in 2015, that was issued in March of 2015 by the Wind and Water Power Technologies Office in EERE, really tried to reframe that question and update it, and really tried to say, what's our value? What's wind's value to the system? What are the real action steps that we need to take to be able to understand what it's going to take to be able to deploy wind in those levels? So it was interesting that as we were drafting this report, and one of the things that's probably most frustrating for people that actually read the report, is that the Wind and Water Power Technologies Office here in DOE cannot make specific policy recommendations and cannot make budget recommendations or budget commitments. And so people really have a lot of questions related to both regional and national policy alternatives, everything from carbon taxes to national or state RPSs, and was really trying to ask that, and many people are very interested in the question, what policies are the right policies that would help us deploy wind? And so DOE in this report had to balance, I call it dancing on a razor blade, where you had to really, you're allowed to inform, you're allowed to analyze, you're allowed to think about the implications of policies, but we really have to be careful that DOE cannot make a recommendation. We need to give you, the local and regional and state decision makers, the information and allow you to be able to come to your conclusions. So this Wind Vision report, as Lisa mentioned, really was a collaboration from a really broad cross-section. It really was an amazing opportunity to work with a number of very dedicated people that are very detailed on both local, regional, state, and federal levels. So one of the things that Wind Vision did was it took a look at what have we actually accomplished? What have we accomplished so far? And did the 2008 20% by 2030 report really get it right? Did we make projections, or were we really significantly off? And the answer was, when you look at what actually happened in 2013 versus what was projected in the 2008 20% report, we actually exceeded almost every substantial goal. The total gigawatts of deployment nationwide was projected to be 48, and we actually deployed 61, which is a substantial increase over the 48 gigawatts that we have. States that were looked to have utility-scale wind deployment, we projected as 35 in the 2008 report, and we exceeded that at 39. And probably most importantly is the market has responded with investments and innovations and technology solutions that have really helped drive down the cost of wind energy. And wind was expected to be $66 to 6.6 cents in 2013, and in fact we're down to 4.5. That's on a nationwide basis. Any questions so far? Okay. The report's objective.
Yes, we can supply everyone with copies of the slides. It's been helpful to have a phone.
The report's, sure, great, be glad to do that. The report's objectives really are to do three specific things. One, can wind be economically competitive across a wide range of market sensitivities, and I'll mention a few of them, both in the short term, the near term, the midterm, and the long term. Can wind be a major player, and understand and model and look at what the actual impacts would be. The second was we really wanted to, the Department of Energy and the Wind and Water Program realized that there's a lot of misunderstanding related to the monetary impacts. And so for the first time ever, the Department of Energy did the quantification and the monetization of what are the costs and the impacts and the benefits of having a lower CO2, of having a reduced water savings. What's the real cost on land use? How many incremental transmission miles, and what would that incremental transmission cost if we look at it from a nationwide modeling point of view? So understanding that quantification was an important attribute. And third was to make sure that as a federal agency, we inform our own priorities and make sure that we make smart decisions about how to use taxpayer funds and how to have the biggest impact that we can have as a federal agency. So many of these next points on the several slides, I'm not going to read all of them. I just want to make a few points, and then you can look through the slides in more detail. You know, wind energy today is material at just over 4.5% as of the end of 2014. So we actually did modeling both on a nationwide basis and on a state-by-state basis. And a lot of the state-by-state basis data is available on the DOE website, and I'll give you that information at the end of the presentation. We did not model just policies that favored wind, and we didn't just take scenarios that said that wind was going to be successful. We really tried to create a balanced approach to make sure that we looked at what are the real costs and what are the things that could go right and could potentially go wrong. One of the things that we did analyze but did not put in the report was really looking at EPA's 111D. And we did try to, and because it was a non-final rule, DOE can't publish a report that makes any kind of analysis on 111D, and until that Clean Power Plan rule gets issued here in the later summer time period, really can't formally produce any of the analytical results. But wind has an opportunity to be a truly substantial contributor to solving the overall state-by-state objectives that are in the Clean Power Plan. On a nationwide basis, at the 10, 20, and 35% levels that we've analyzed in our models, we could provide over 50% of the EPA's 111D objectives on a state-by-state basis. So many in the group here is probably very familiar, so I won't go through kind of wind's overall story. That is how much the cost of wind has come down since the early 80s, how much wind has been deployed, and how dispersed that's been over a number of states, creating opportunities for manufacturing, for local jobs. It's a really, really fabulous story, and the Wind Vision document tries to recap the status of where wind power is today in a really detailed way that gives people facts about what the current deployment of wind is. The Wind Vision looked at and did this quantification of what actually has the existing wind already had the opportunity to impact, and then looked at that on a future basis to say, what can the future of wind do? So we looked at things like carbon dioxide. We looked at SOXs and NOXs. We looked at water consumption. And you could see that the wind has already had a really substantial impact in terms of its ability to affect those kinds of attributes today, everything from water consumption of equivalent to 116 gallons per person up to 270 million barrels of oil. Really substantial contributions to those impacts today. But as most of the people are very familiar with it, anybody that's ever looked at wind, the wind story is a very jagged one. Even though the deployment line that you see in the middle here is continuing to go up in terms of cumulative capacity, the impacts of federal policy on the actual deployment of wind and how the industry makes its investments is very sensitive to federal policies. So each time that the PTC has either expired or has not been renewed timely, the market simply takes multiple months to make those investments for the following year. And so if the production tax credit to wind developers and wind generation producers is not available, and it's not just, you can't renew it in December of the year and then expect that you'll have an impact on the following year. It really is a year to 18-month plan-ahead cycle in terms of investments. So when the PTC on a federal level is not given a strong signal that it's available, then those investments significantly decline. But clearly the most significant one is the system of investments is becoming even more sensitive when you look at the 90% drop between 2012 and 2013. So the Wind Vision report itself. We actually had an opportunity to look at a number of different attributes for wind. We got to look at how much wind resource is out there, and if we were to deploy really large volumes of wind at the levels of 10, 20, and 35%, which is what we call our study scenario, that is the levels that we're analyzing and modeling to see what the impacts would be. Clearly, there's significant wind resources well above what would actually need to be deployed. Land use, we calculated the actual use for a number of ways of looking at wind plants. We looked at how much actual land is used for putting the cement stations in, and how much land is not available if, in fact, foundations and roads are built. And the calculations ended up being 0.04% of U.S. land. It's slightly higher if you were to continue an entire wind plant's land area, and we did those calculations in the report also. But wind plants are often deployed in such a way that they can still be used for multiple purposes besides just wind generation. In our modeling, we did get a chance to look at every state and whether or not each state is expected to generate wind, if in fact our wind cost projections in the future are achieved. And the answer was, in all 50 states, when you look at modeling on an economic basis, wind is deployed by 2050 at a utility scale. So this isn't a regional question anymore. This really is a national question related to being able to make investments in wind and the value of wind. One of the crucial questions that we had to look at was the nature of transmission expansion. It's such a, as you know, as a team, it's such a volatile and strongly emotive conversation related to transmission and both transmission servicing the local area and transmission servicing multiple states that are dealing with each other. So we really wanted to look at how much additional transmission capacity would be required. And the answer was to achieve levels of wind vision of 10% by 2020, 20% by 2030, and 35% by 2050. The answer was the amount of miles that we've been installing over the last 5 years is about the number of miles that we would need to continue to deploy if we were to achieve those kinds of wind penetration levels. So we've been deploying on average 870, and we would need about 900 circuit miles per year added through the period through 2030. So that transmission calculation on a nationwide basis was trying to answer the question, how much transmission do we really need to be able to support really robust deployments of wind? You can see here some other notes on grid integration. Obviously, manufacturing and supply chain is crucial for local and regions to understand jobs and understand local investments. And then we've already talked a little bit about the wind power cost. And we do anticipate that the cost will continue to reduce. And you can see the numbers there, 24% by 2020, 33% by 2030, and 37% by 2050 is what our projections are based on all the best information we have. So when you put all that into the system and you look all around and you say, what is it that wind can really do? What impact can it have? Is there a value that we should be thinking about when we think about, should we be thinking about local and regional and state and federal policies? What's the real value for wind? And this slide is probably the one that I would point to more than any other to give you that picture. So in our modeling, and I want to take these one by one, in our modeling, as we project 35%, and this isn't a target, this is saying if in fact we hit a scenario where wind was to deploy by 35% by 2050, the first question we wanted to answer is what's the cost? What's the cost in terms of rates, the cost on the local regions, the cost that the consumer would bear if you were to deploy 35% of wind? And interestingly, using EIA's data for the future cost of natural gas and for coal and comparing that to wind energy's cost, there's actually a savings. People really have this misunderstanding that wind energy is a significantly more costly alternative. And the answer is that on a nationwide basis, across all the energy sectors, if you were to deploy 35% wind by 2050, you'd actually have $149 billion of electricity cost savings. Now, in the short term, through 2020 and 2030, the report looks at that, and there is a cost. Rather than a 3% savings, in the shorter term, there's a 1% increase in those costs. And all those costs are detailed in the calculations, and you can kind of see how the Department of Energy did those calculations inside of the Wind Vision report. Next, you can look at some of the benefits. We have a number of ranges for each of the benefits in GHGs and air pollutants and PM 2.5s and water. These values on this particular sheet are the central values. They're relatively conservative, but the ability to impact $400 billion in savings, actual savings to the U.S., on a global basis, $400 billion related to GHG reductions, and $108 billion in terms of lives saved and the health impacts of air pollution, and 260 billion gallons of water for regions of the country really have significant water usage for utilities. The reason to tell this story from the department's point of view is to really let the local and regional policy and decision makers and the public really understand that when you're talking about a PTC that cost $10 billion and you're comparing that to GHG savings on a conservative basis of $400 billion, that the cost for deploying really is significantly overcome by the benefits. And if there's a single story that I would hope that somebody that reads the executive summary or sees a brochure about Wind Vision that they would walk away with is that the accumulation of benefits in CO2 and GHGs and air pollutions and water really is overwhelmingly positive as compared to the costs that it takes to deploy wind. When you do that monetization of all the impacts that affect the value of wind in the system. And many of those monetized impacts, as you know, are not in the economic system. There is no value for a cost of carbon. There is no value for a local regional's use of water consumption that a power plant takes in terms of its impact to the overall system. So this is really our attempt to empower the reader with more information to be able to understand that. Obviously, when you're talking 600,000 jobs and $1 billion a year in land leases and $3.2 billion in local tax payments, those additional impacts add the value to the wind equation story. Now, there is a cost of land, and again, this is 1.5% is the contiguous area. That's the total area used by a wind plant. And clearly, there are very important public acceptance, wildlife, radar, and other use key issues that must be talked about when you talk about deploying wind. But overall, the ability of wind to add a value is really tremendous. I won't spend a lot of time, but I will show you the state-by-state deployment information. This is what's currently deployed for wind in 2013. And this is, don't take the size, it's a relative size related to, that's not how much land use, that's not how much land area is being used by a wind plant. It's just a relative size for the number of gigawatts that were deployed through 2030 and 2050. And you can see that one of the things that does happen is that all parts of the country get engaged. So we're not stopping with just the Wind Vision report. We have produced a number of, we've published our first follow-on publication to the Wind Vision report. One's called Enabling Wind Power Nationwide. And it really looks at saying as wind turbines continue to get bigger and are accessing higher speeds at higher heights, what does that do to the cost of energy, and what does that do in terms of regional deployments? And you can see that in the orange on the bottom right of this chart, those are the areas that as hub heights move higher and higher become cost effective. And so this is one of several follow-on reports. We've also got a number of program investments that are happening. We're investing in new technologies for taller towers to access these higher wind speeds, and we're looking at how to work with industry to expand and create larger blade sizes that make the system more cost efficient and more cost effective. So overall, the takeaways that I would offer is that when you read the report and get a chance, if you do have an opportunity to read it, wind research and innovation really remains critical. You have to continue to reduce wind cost over time. And as you continue to make the investments in technology, you can reduce your long-term need for policy. Next is that the overall wind deployment really are expected to exceed the value when you look at the quantified benefits of deploying large amounts of wind. It tells us that the grid, we know this from several states that have very large deployments of wind, can be effectively managed. We have 2 states that are over 25% of their state-based electricity is now with wind penetration. So the ability of a state to operate its grid reliably and cost-effectively, those 2 states have some of the lowest amount of rate increases, really tells us that wind does not create significant instability if it's managed correctly and into the grid management system. And then the Wind Vision report does create and does have, both in its main document and in its appendices, a really comprehensive roadmap that all the study and report participants had a chance to contribute to. What are the right kinds of activities that we should do to continue to help deploy wind? So the Wind Vision is available at www.energy.gov/windvision. If you just search for wind or Wind Vision, you can find this particular report. There's a 3-page summary, there's a 40-page summary, there's an 8-page brochure, and then the main body of the report is a little over 300 pages, and there's 350 pages of appendices. So there's a lot of detail available.